Hello. In this video, we're going to take a look at radian measure, which is a bit different than our normal degree-focused measure. Now, what exactly is a radian? So, if I take my circle here and I extend, let's say, a line from the center out to the outer edge, and then I extend the same from the center out to about here. Now, as we know, this line from the center to the outer edge is called a radius, or r. So that's just that distance. So we got r here, and then we got another r here. Now, the radius is a fixed unit, and it's roughly basically the circumference divided by 2 pi. Now, a radian is basically this angle in between here. You put theta, and it corresponds to what we call the arc length, or A. So basically our angle here, theta, is going to be equal to the arc length over the radius. So this is going to be like our angles. In an actual radian, a radian itself is when the arc length A is equal to the radius. So that's when this and this and this are all equal. That's essentially what 1 radian is. And this all kind of stems back to our definition of, like, say, a circumference of a circle. And so if we look at the circumference of a circle, no matter what, circumference is always going to be equal to 2 pi times the radius. So if we think about that, the number of radians that are going to be in the full circle, if I go all the way around my circle, well, the number of radians in a full circle is going to be equal to 2 pi. So the number of radians, or theta, if the arc length is 2 pi, it's going to be 2 pi over r, or kind of 2 pi radians. And that gives us kind of this relationship. Because the other thing we know about, like, a complete circle is the angle in a complete circle is 360 degrees. So we also know that 2 pi is equal to 360 degrees. And we can actually make another, just like kind of divide both sides by 2. And we can actually make another kind of relationship between them, and that's pi, or pi radians, is equal to 180 degrees. This is kind of our kind of core relationship. This is going to be the ratio we're going to use to try and find out how many degrees are in a, or how many degrees relates to how many radians. So for instance, let's take a look at, I don't know, let's take a look at, say, 90 degrees. I want to know how many radians is that. So I take a look, and I know that 180 degrees we know is equal to pi radians. So let's say if I have pi over 180, I know that's going to be equal to x radians over 90. So I just do a little bit of cross multiplication. 90 times pi over 180 gives me x radians, and that's going to be actually pi over 2. I kind of want to keep it in this fraction because it actually just makes things a little easier. Or if I give it something maybe a little bit more complicated, like let's say, I don't know, 270 degrees. Oh, 270. How many radians is that? So let's see. First of all, we take pi over 180 is equal to whatever radians over 270. So cross multiply, so it's 270 times pi over 180. And that gives us, let's see, 4.71 radians. So 4.71 radians. So you use this as kind of like a really good kind of catch-all for the number, or for the way we can convert between the two. So let's go back the other way. So let's see if we can convert from radians to degrees. So if I have, let's say, I don't know, 3 pi over 4 radians. Most of these radians are going to involve pi, just because like 360 is 2 pi radians. So a lot of these are going to have pi. Otherwise, we get like nasty decimals. So we just want to keep them as these kind of pi fractions. So the first one is 3 pi over 4 radians. So how many degrees is that? So I know that I have this relationship, and it's going to be 180 equal to kind of pi. So I'm actually just going to flip that around. So doing the other way, pi over 180, now I'm going to do 180 over pi, and I know it's going to be equal to whatever degrees I have over, in this case, 3 over 4 pi. When I do the cross multiplication, 3 over 4 pi divided by pi, it's 3/4 of 180, so I actually get 135 degrees for my kind of unknown. So I can actually kind of go backwards and do that. So it's always going to go back to this kind of 180 equal pi relationship when I convert between radians. Now, the last thing I'm going to talk about is kind of angular velocity. So angular velocity is basically, we give it this kind of symbol, and it's basically how big does an angle theta grow over time t. And that's angular velocity. So, and this is generally in kind of radians. Sometimes degrees, but generally in radians, and this is kind of the time. This is my kind of angular velocity. And don't be confused by the word, but it just means how big does an angle get over time. Velocity. So, in your example number 3, it says the London Eye has a wheel diameter of 135 meters and completes one revolution every kind of 30 minutes. So if it completes one revolution every 30 minutes, so if I do that here, so one revolution per 30 minutes, so that means it actually goes around once in the circle. So if I start here and I go around the circle, that takes 30 minutes. So that's going from 0 radians all the way to 2 pi radians in that 30 minutes. So the first question is, what's the angular velocity, or in radians per second? So first thing I do is I convert. 30 minutes times 60 seconds per minute min gives me 1800 seconds. My angular velocity is going to be my angle in radians over time. I know that goes around once, and one time around is 2 pi radians over 1800, in this case, seconds, 13 seconds. So rad seconds. So, and that equals, if I want to get really down, 0.0035 radians a second. So that's a really, really quick, or I guess, relatively quick, kind of revolution around. Now, the second part of this, and I'll kind of extend this down, is it's asking, how far does a rider travel at 18 minutes into the ride? So 18 minutes is not quite a whole revolution, but it's kind of part way. So how far does it get within that whole revolution? So I'm going to use my kind of circumference kind of formula, and we know that circumference is equal to 2 pi r. This is the key part. But we also want to know the distance it travels. So we know that one time around is 2 pi, and we know what r is, or at least we can figure it out. So r, well, we've given the diameter in the question at 135 meters, so 135 divided by 2, that's our r, and that is equal to 135 divided by 2, get a crush calculator, 67.5 meters. So that's my r. So this is just one time around 2 pi r, but I have a fraction of that. So, and the fraction is it only went for 18 minutes. So my distance is going to be my kind of circumference, 2 pi r, times 18 over 30, because 18 minutes of the 30 minutes it takes to do one kind of full revolution. So 2 pi times 67.5 times 18 out of 30 minutes for the full revolution gives me a grand total of 254.46 meters traveled. And that's like number 3 from our example. So this is a good introduction to radians and degrees and how to convert between the two of them, and a little bit of a dipping our toe into angular velocity. Stay tuned for part 2 of these lessons, where we'll talk about the special angles in cast rule and how that involves radians.